Hello viewers, and welcome back to my channel. This is the continuation part 2 of our video on partial differential equation using Dr. Asmaa AI lecture notes. Okay, and then in the last previous video you can watch it. I will put the link in the description. So in this particular one, we are here on the solutions and solution technique to partial differential equation. And don't forget that my name is Master Talker Kingsmatics, and I have a full video on any topic at all you want in maths, physics, and calculation in chemistry. Just tell us the name of the topic at the comment section, and we'll send you a link that will explain it from the beginner level to the advanced level. Okay, so let's continue. Now, they say that there are many applications of partial differential equation in the study. In our study, we will adapt the most important partial differential equation that arise in various branches of science and engineering. Now, the major three partial differential equation you need to know. Number one is the heat equation. Number two is the wave equation, and number three is the Laplace equation. It's in the next page. We'll look at the Laplace equation. Okay. Now, in writing these equations, you need to know the equations. In writing this equation, it is very simple to write. All you need to know is the format. Okay, I'll just tell you. Now, in heat equation, the heat equation is simply partial squared u over partial s squared is equal to 1 over k partial u over partial t. Okay. Now, from here, from the heat equation, we get the wave equation. In the wave equation, the difference is that the right hand here, everything must be squared to get the wave equation. Remember, we start from the heat. From the heat, you can get the wave. From the wave, we can now get the Laplace. Okay, and then using t here is that a function of time, but that doesn't mean you cannot use any variable you like. We can say partial square z over partial s squared is equal to 1 over k partial z over partial y. Okay, we can use the same thing. Whenever you see any equation in this form, it is called the heat equation. The heat equation. And then this k is a product, is a constant, a positive constant. Sorry, not a product, a positive constant. Now, from here we can get the wave equation. The wave equation is just to square everything here. So I'm going to have partial squared u over partial s squared is equal to 1 over k squared partial squared u over partial y squared. Remember, if here is u, here will be u. As simple as that. That is your what? The wave equation. Okay. In the wave equation, everything is squared. That's the difference. The heat equation, only the right hand side is squared. We can equally say, sorry, t. Let's say t here, t. So, but if we want to use x, y, z, we say partial squared z over partial x squared, okay, is equal to 1 over k squared partial squared z over partial y squared. Okay, so that is it. So that is for the wave equation. Please, we start from heat. From the heat, you wave it. From the wave, you now go to Laplace. Now, for the Laplace, the Laplace is very simple. How do we write the Laplace equation? The Laplace equation, the difference is that everything is going to be squared, but this man will not be there. This man will not be negative. So the Laplace said partial squared z over partial s squared is equal to just partial squared z over partial y squared. That is the Laplace. Why some people write it in this form, some prefer to write it in the form partial squared z over partial x squared. This one will now come to this side to have plus partial squared z over partial y squared is equal to 0. Some prefer to write it in this form, but me, I prefer to write it like this. So without looking at this place, let's write it together. So writing it together, remember, you start from heat, then you wave it. From waving it, you go to Laplace. So for heat, let's start from heat. Heat is what? Partial squared u over what? Partial s squared is equal to what? 1 over k, then partial u, partial t. Okay, as simple as this. Or you can use x, y, z by saying partial squared z over partial x squared is equal to what? 1 over k partial z, the same z over partial y. This is the heat. From heat, we will now go to what? Wave. From heat, you wave it. So from wave, the difference is that everything here is going to be squared. So I'm going to have partial squared u over partial s squared is equal to 1 over k squared partial u partial squared u over what? Partial t squared. Or we say partial squared z over partial s squared is equal to 1 over k squared partial squared z over what? Partial y squared. And Laplace equation. Now Laplace equation is just that everything here will now turn to negative. That's all. So what do we have? Partial squared u over, or partial squared z rather. Let's just go straight to here. Partials, or you can even any one you like. Okay, let's just do it normally the way we have been doing the rest. So we're going to have what? Partial squared u over what? Partial s squared will now be equal to what? Minus partial squared u over partial t squared. Or you say partial squared z over partial s squared is equal to what? Minus partial squared z over partial y squared. Like I told you that some people would like to bring this to this side. If you bring it to this side, the same thing, and you equate to 0 is the same thing. So that is that. So another thing we'll talk about, let's go to the next page. So on this next page, you see what I'm saying. So let me zoom it. Okay, zoom. So you see what I'm saying, that sometimes they bring it to the other side and equate to 0. It's still the same thing. So they say that what? A function u is harmonic if it satisfies the Laplace equation. Yes, any equation that is harmonic is an equation that satisfies the Laplace equation. They can ask you that in exam. They can ask you to verify if a particular equation is harmonic. And what do you do? Once that equation satisfies the Laplace equation, then it is harmonic. Okay, so now let us solve this particular example. This example they gave us, they say we should verify this example. We should verify if u, which is equal to exponential 3x cos 3y, is harmonic. How do we know if it is harmonic? It must satisfy the Laplace equation. And the Laplace equation say that what? We have x and u here. So the Laplace equation is going to be partial squared u over partial x squared will be equal to negative partial squared u over partial y squared. Okay, so that is the Laplace equation. So the first thing we need is what? To get our partial u partial x. And partial u partial x means differentiate this with respect to u. So to differentiate with respect to x, to differentiate with respect to x here, if you have exponential 3x, the differentiation means differentiate here and bring it to the back. So differentiate 3x is 3. So bring the 3 back and repeat the same thing. Very simple. Okay, so the differentiation of this will now be what? 3 exponential 3x, repeat the rest, cos 3y. Okay, so let's get the second derivative. Partial squared u over partial s squared. The second derivative is going to be differentiate here again. You have 3, bring it to the back. 3 times 3 will give you 9 exponential 3x cos 3y. Okay, that's the second derivative. So let us now go to, let us now get partial u partial y. We have done for x. Partial u partial y will differentiate. Anytime you are differentiating cos, let me write it here, cos 3y, just differentiate inside here, it will give you 3. If you bring the 3, differentiate cos something to give you what? Sine. You understand? I think cos is minus sine. Yes, sine is cos is minus sine. So that means differentiation of the 3y is 3. Okay, differentiation of cos 3y now will now give you what? Minus sine 3y. So repeat this man that is here, exponential 3x. So if you bring them together, it's going to be minus 3 exponential 3x, then sine 3y. Okay, so now to get the next one, partial squared u over partial y squared will now be equal to what? The same thing now. Differentiate inside here to give you what? 3. The 3 will now come to the back and multiply this to give you minus 9. Repeat this, exponential 3x. Differentiation of sine something is just cos that thing. Okay, so you see that the difference between this man and this man is just negative. So therefore we have gotten that partial squared u over partial s squared is the same thing as negative partial squared u over partial y squared. So since it has satisfied this Laplace equation, therefore this is harmonic. This is harmonic, as simple as that. Okay, so that is what we are required to do. So it's indeed a harmonic function. Yes, it's a harmonic function. So that is that. Very simple. Just once it satisfies the Laplace equation, then it is harmonic. So the next thing is that they say solution of linear partial differential equation. Solution of linear partial differential. They say a solution of partial linear differential equation is a function u which is equal to g of x and y that satisfy the differential equation. It's very simple. So they say that what verify that this equation, okay, satisfy the wave equation 6. And remember the wave equation, even if they didn't tell you that it's equation 6, you know wave equation. Remember that you start from heat, then you wave it. So the heat said, okay, since we are having x and t here as the function, remember this k is a constant, x and t as a function. So we are going to have that the wave equation, wave first. I cannot write wave before without heat. So I cannot write the wave without the heat. It's from the heat it will now wave you. So that's how I remember it. So the first thing I write is the heat before the wave. So let me write the heat first. So for heat said partial. Remember that we're having this is u and t. It's even written here u and t. So partial u for partial squared u over partial x squared will now be 1 over k, then partial u over partial t. So this is heat. But for wave we're going to have just square everything here. Partial squared u over partial s squared will be equal to 1 over k squared of partial squared u over partial t squared. So having this in mind, so what we need to do is just to solve. So let us solve. Permit me to clean all this rubbish. Okay, so they gave us that u is equal to sine x, then cos t kt. Okay, now we want to get partial u partial x. We are differentiating with respect to x, so and the differentiation of sine is just cos. So this is cos x. Repeat this man, cos kt. Very simple. So to get the second derivative, partial squared u over partial s squared will now be differentiate cos. You have minus sine x. You are not differentiating here because it does not have x, so repeat it, cos kt. Okay, so now the next thing we need to get is let me shift to this side. Sorry, come down here and then shift to this side. Okay, let me clean here. So the next thing to get is for your t. You have gotten for x, so let's get for t. So we need partial u over partial t, which will give you, differentiating kt will give you k. Use it and multiply everything, so it's going to give me k. Okay, k sine x. I'm leaving this the way it is. Then the other one, differentiation of cos will give you minus sine, so I'm going to have minus sine kt, so which will give you minus sine x, then sine kt. Okay, second derivative, partial u over partial t, squared. The second derivative will now give you, differentiate here again to give you k again. Use that multiply, have minus k squared, then repeat this one, sine x. Then differentiation of sine is just what? Cos x. Okay, so if you notice this, you see that the problem here is that okay, let us check. Okay, let's see if it satisfies it. So we have that what we need to satisfy is that partial squared u. Okay, let's write the one we have. We have partial squared u over partial s squared must be equal to 1 over k squared partial squared u over partial t squared. Let's see if it satisfies that. So if I put this one now, we got this one as this. let's see if they will give you the same thing. We got this one as minus sine x cos kt is equal to, leave your 1 over k squared there, so put the other one. To put this one, we got it as minus k squared sine x cos x, right? So you see that k squared is taking care of k squared, so we're having that minus sine x cos kt is now equal to minus sine x cos kt, kt. You see, they are equal. So once it's equal, you say that what? Indeed, it satisfies, is the solution. You say that indeed that thing given to you is the solution. Where am I? My board is lost. Oh, let's go to the next page and go to previous page. Okay, so this is my board. So indeed, this u equal to sine x cos kt is the solution. Okay, so we go to the next one, and the next one is that they say we should verify if this satisfies the Laplace equation. We should verify if this satisfies the Laplace equation. So let us solve that. So to solve this, I have to scroll up so that I can be seen. Then I'll clean my board. Okay, so now to solve this is very simple. The same way, we have that our u is equal to what? X squared minus y squared. So and the Laplace equation say that what? Partial squared x and y, so partial squared u over partial x squared must be equal to minus partial squared u over partial y squared. So let's see if this satisfies. So the first thing I need is what? Partial u partial x, which is giving me differentiate with respect to x. I'm going to have just 2x. This is a constant and they are not together, so I'm not bringing it here. But if they are together, I'll bring it here, but they are not together, so differentiation of this is gone, 0. So the second one, partial squared u over partial x squared, will give you what? Differentiate here, have what? You have 2. Okay, this one is gone. So let's do for y. Partial u over partial y is giving me minus 2y. Differentiate here is 0. You have minus 2y. So partial squared u over partial squared y will now give you, differentiate here, minus 2. So we want to see if it is going to satisfy. Partial squared u over partial x squared must be equal to minus partial squared u over partial y squared. So if you substitute, we got this one as 2 is equal to, minus is here, and we got this one as minus 2. So if minus minus, we are seeing that 2 is equal to 2. So therefore, that is the solution of the Laplace equation. So it's satisfied that, so indeed is a solution. So we go to the next one. They say we should verify if the function d satisfies the wave equation. Okay, so let's see if it satisfies the wave equation. So permit me to clean here again, or let me even just solve it down here. Let me solve it down here. So we have that f of x plus ky kt. Okay, so first thing we need is f of x like this, and f of x like this, simply as saying partial f over partial x. Don't forget that differentiating with respect to x, that is differentiated, you have 1. So you have 1. So this will just be f prime. This will just be, how do I put this now? This will just be f prime. Let me call it f prime of that x plus kt like this. So the second derivative again, f x will now be partial squared f over partial x squared, which will give you just f prime of x plus kt. Okay, so now let us now go to t. For t now, f of t will give you the prime here. Don't forget it should have x here, and this prime here should have x. So this will now be differentiate. We have that f of x plus kt. So differentiate this kt, you are having k, so you bring it to the back, it's going to give you k, then f of x plus kt like this. This is what it's supposed to give us. Okay, so let me have okay, sorry, we are not supposed to put this prime there. In fact, we're not supposed to put this. Sorry, we're not supposed to put this. Yes, so that's what it's going to give us. Okay, so you now see that FTT will now be differentiated here again. You have k coming to the back, it will give you k squared f of x and f plus kt like this. Okay, now having this, you now write you have gotten the two things you need. These are the two things you need, this one and this one. So you now write your is it wave equation they said? What did they say in that question? Let me check. Okay, wave equation. So now write your wave equation. Remember the heat before you wave. So in wave there is squared everywhere. So we want to check if fxx must give you the same thing as 1 over k squared ftt. That's what we want to check. So fxx is this one. So we have it as f of x plus kt is equal to 1 over k squared. This one we have it as k squared f of x plus kt. So see that this is taking care of this. So we are having that f of x plus kt is equal to f of x plus kt. So proved. Okay, so proved. So we now move to the next page. Let's move to the next page. Next. So on the next page, what do we have on the next page? What page is this? Page 6. Okay. So on the next page, we're asked to verify. So you're going to do this one, or let's just do it. If this satisfies the heat equation. So let me increase. Okay, so now, so we are given that u is equal to exponential minus kt then sine x. We want to know if it satisfies the heat equation. So we are going to have that first thing, and the heat equation said u of xx is equal to 1 over k. There is no square in this one. U of t like this. So first of all, ux is to differentiate with respect to x, and the differentiation of sine x will give you just cos x. So you bring exponential minus kt then cos x. You are repeating this one. So then u of xx, the differentiation of sine cos is minus sine, so we have minus exponential minus kt then sine x. Okay, you see that. So the next thing we need is what? U of t. U of t is what? To differentiate this with respect to t. So differentiation of minus kt will give you minus k. So you bring the minus k outside and then repeat everything. Exponential minus kt then sine x. So we want to check if it will want to check that if uxx will be equal to 1 over k ut. So let's check it. So uxx gave us this. Gave us minus exponential minus kt then sine x. Is it something as 1 over k into this one? Gave us minus k exponential minus kt then sine x. So you see that k is taking care of k, so they are equal. We are left with these two things, so they are equal. So therefore, indeed, it is the solution of the wave equation, or it satisfies the wave or the heat equation. Sorry, not wave equation. From the heat wave, so the heat equation. Okay, so the next one now, they say solution. We are now here. Solving linear partial differential by basic integration. This one is very simple. So they gave us a question. The first question they gave us said that that let z be a function of x and y. Okay, and they gave us that they give us that z of x is equal to 2xy. Okay, so what do we do? By direct integration, just put integral sign everywhere. So we have the integral of z with x like this, dx. Okay, will now be the integral of 2xy dx. Okay, so now you can change this one if you like to be, this is the integral z with small x here, is something as saying partial z over partial x. Okay, you now have that dx here is equal to the integral of 2xy dy. Now if you integrate, you see that the x is taking care of the x, then integration is taking care of differentiation, so I'm left with just z here. You see that? So this z, which is a function of x and y, okay, will now be equal to, if you integrate 2x, in fact if you bring out the 2 outside, if you integrate x, it's going to give you x squared, add 1 to the power and divide by the new power, then attach your y to it, then plus a constant. But the constant here is going to be a function of the other one. If you differentiate with respect to x, your constant is going to be a function of y, a function that is respect to y. Okay, so I'm going to have a function of y. Why? Because I integrated with respect to x. So but if I integrated with respect to y, maybe the dy here, I'm going to have f of x here. So my answer simply becomes, this take care of this, my answer becomes z is equal to what? S squared y plus f of y. As simple as that. I hope it's not difficult. So we go to the next question. So let's solve this particular one. Okay, so to solve this one, you permit me to clean all these things. These are very, very simple something. So I'm going to have that they gave us that ux is equal to 0. Okay, and this is simply saying partial u partial x is equal to 0. So if I integrate now, I'm going to have the integral of partial u partial x will now be equal to the integral of 0, with respect to x, like this. So if I integrate here, see that the x is taking care of the x, the differentiation is taking care of integration, I'm left with u. So u is equal to what? Integral of 0 is still 0. Integral of 0 is still 0. So I'm going to have 0 plus a function of u, or a function of y, because I did with x here. So a function of what? Y. So 0 plus anything is empty, so u is just a function of y. And that is the answer to the problem. As simple as that. And don't forget that this your u is a function of x and y. So and I have that f is a function like this. So that is it. Okay, so as simple as that. So let's solve the next one. We have solved okay, so look at this particular one. Let's solve this particular one now. So you must consider what is given here before you are solving anything. So in this case now they changed it. Look at what we are given in this case. They say that u is now a function of x, y, z. So if it's a function of x, y, z, look at what you are going to do. The same thing, but the difference is just the arbitrary constant you are going to bring in. That constant is not just a constant, it will be a function. So this thing is something as saying partial u partial what? Partial x, because it's being differentiated with respect to x, is equal to 0. So we're going to integrate with respect to the same x. The u dx dx is equal to what? 0 dx. So here, don't forget this, don't cancel though. I'm just doing this because I'm teaching you. We are not cancelling. Just so that this will cancel this in your mind. Don't cancel it. And this will cancel this in your mind. So we are left with just u. And this u, don't forget, is a function of x, y, and z. In this case, is equal to integral of 0 is 0 plus the function you are bringing now will now be, we have used this one, will now be y and z. Y and z. That's just the difference between them. Y and z. You understand? So 0 plus anything is empty. So u of x, y, z will now be f of y and z. As simple as that. Okay? So let's solve the next one. Let's solve this one. Okay? So permit me to clean again. These are very, very simple and cheap. Okay. So now, to solving this one, I have that our u is equal to a function of just x and y. Sorry, what page was that page? Okay, this is what we want to solve. Sorry. Oh, so you can just press this erase and then it will clean everything. Wow. Okay, I've learned that one now. No, I'm still learning this my app, so don't mind me. So I have where is it? We want to solve this particular one. So we have that our u is u that is a function of x and y. Okay, and they gave us that our u of x is equal to 2x. Okay, so the same thing, this thing means partial u partial x is equal to what? 2x. So if you integrate, integral of partial u partial x with respect to x is equal to integral of 2x with respect to x. So this take care of this. Don't cancel, just cancel in your mind. This take care of this. So I'm having u that is a function of x and y will now be equal to, integration of here will give you 2x squared over 2 plus what? F of y. Don't forget, because I did integrated with respect to x, so therefore u of x and y will now be equal to 2 take care of 2, have x squared plus a function of y. Now, but there is something they gave us. If you look at that question, they gave us something. They gave us that u of 0 and y is equal to ln y. So here, that means anywhere I see x, I'll put 0. Anywhere I see y, I'll put y. Okay, so it will help us to get this function we are looking for. So we are going to have that what? U of 0 and y will now be equal to what? 0 squared plus what? Plus a function of y is equal to, they gave us as ln y. So 0 squared is y. So therefore, our function of y will now be equal to ln y. You understand? So 0 squared is, so f, this is now equal to this. You understand? So from there, we have gotten that our u of x and y will now be equal to what? X squared plus, we have now gotten this to be what? Ln y. So ln y. And that is the final answer. I'm sorry that I'm squeezing it. It's because I don't want to shift from my question. So you see, they got the same thing, x squared plus ln y. So we move to the next page. So on this page now, we have page 7. So they gave us a question to solve. Okay. So in this question, they said that u is equally a function of x and y, and they gave us that uy is equal to 2x. Okay, so this thing means partial u over partial y, I hope you know, is equal to what? 2x. So if I integrate, the integral of partial u over partial y, you must integrate with respect to y, is equal to the integral of 2x dy. Sorry, it must be dy, not partial y. So this take care of this, and this take care of this. I'm left with u that is a function of x and y is equal to the integral of the 2x is just there. The integral of something with a constant, everything here is a constant with respect to y, is just to attach the y, then plus what? A function of x. Why did I put a function of x? Because I integrated with respect to y, so a function of x. And that is the answer. You are good to go. So the next question here, okay, let me just move to the other side. Okay, the next question here said, where is it? That uxy is equal to 2x. Okay, so this is partial squared u over partial x partial y is equal to 2x. Okay, so if I integrate, integral of partial squared u over partial x partial y, the first integral will now be with respect to x. That's the first integral, so dx. So I'm going to have the integral of 2x dx. So you see that the x is taking care of the x. Integral will take care of one of these. So I'm left with what? Du over dy. Sorry, partial u over partial y. So partial u over partial y. Okay, will now be what? Integration of this will give you 2x squared over 2, which is just x squared plus a function of what? Y. Why? Because I integrated with respect to x, so a function of y. So we have to integrate again. So to integrate again, I'm going to have the integral of what? Partial u partial y dy now. the y now, because I'm having this, is equal to what? The integral of what? 2x squared over 2, which is something as just x squared, because the 2 will take care of each other. So it's something as x squared. So 2 taking care of 2. I'm having x squared plus a function of y. Then everything you are integrating it with a function of y. So this is now integrating this. Integrating this will give you x squared, attaching that y there. Don't forget that this is taking care of this and this is taking care of this. I'm left with u, that is a function of x and y. Okay, integrate to bring this, you attach y to it, plus integrate this one. Remember that this is a function of y. Integrating it is going to give us the integral of that function of y with respect to what? With respect to y. Okay, then plus a constant, and that constant will now be what? Another function of x. Why? Because the new integration was with respect to y. It was with respect to y, so you now attach a function of y. And the integral of a function is another function. So we can say that this is what? S squared y plus, let me say, m of y plus g of x. So this is the final answer. Okay, so that is that. That is that. The next page. All right. Okay, so I think we are done with everything concerning solution. So the next thing we'll now look at, this is an assignment for you to look at. Then tell us the answers, 1 to 9 questions. Tell us the answers at the comment section. If there's any problem, you can tell me. We'll solve it together. Okay, so let's go to next page. So on this next page, we're now talking about formation of partial differential equation by elimination. And that elimination could be elimination of arbitrary constant or elimination of what? Arbitrary function, any of the two. Okay, so these are the two things we are going to do, and then I will stop this particular video. So in the next video we continue. Okay, so now let's move. So the first question here, we'll go straight to solving question, and the first question here says the first question here said that z is equal to ax plus 1, okay, sorry, 1 minus, so sorry, 1 minus a y plus b. Okay, make me to shift like this. Okay, so now how do you form a differential equation? We form a differential equation by eliminating the either arbitrary function or arbitrary constant. The arbitrary constants here are a and b. We want to eliminate anywhere we see a and b. We want to remove it. And how do we remove it? We remove it by differentiating, and we differentiate according to the number of independent variables we have. In this case, we have 2 independent variables here, x and y, or according to the constant. I think it's according to the constant, the number of constants we have. Yes, we have 2 constants here, a and b. So we're going to differentiate 2 times, or according to the variable. Can I remember? I think it's according to the constant. Yes, we are going to differentiate twice. So the first differentiation will give you, or just find a way to eliminate it. Just find a way to eliminate it, but always differentiate according to the number of constants. Yes. So let's differentiate this with respect to x. So I'm going to have partial z, partial x. Remember that in the beginning of the video I told that this thing can be replaced with what? Z with small letter x, which we can equally replace it with what? Just p. Okay, all of them, they mean the same thing. So this is just, let us differentiate here with respect to s. There is no x all this place, so everything here is 0. So differentiation of ax, you can call it equation 1. So the next thing is to differentiate with respect to y. So partial z, partial y will give you equal to what? This is something that says zy, which you call what? Q. Is something as q. So let's now differentiate here with respect to y. There is no y here, 0. There is no y here, 0. So differentiating this with respect to y is the coefficient, which is 1 minus a. Okay, but we have already gotten that our a is something as p. So therefore we have that q is equal to 1 minus p. You see, from this place now, you see that everybody, all the constants are gone, and then all these things are the same derivative. So we have gotten our answer. This is the partial differential equation. If you don't want to write it like this, you write it as what? Partial z over partial what? Partial y is equal to what? 1 minus partial z over partial x. So this is the differential equation. Or you can bring this to the other side to write that partial z partial x plus partial z partial y is equal to 1. Or you say that what? Your p, remember that this is something as zx plus zy is equal to 1. Or you say your p plus your q is equal to 1. As simple as that. So let's go to the next page. See, very simple. So second question. Let me increase my brightness. So move this to this side. So this one said we should find the partial differential equation by eliminating the arbitrary constant. We have that our z is equal to ax squared plus by squared. Okay. So in this case, what do? Differentiate. We're going to have partial z over partial x, which we can call z small letter x, which we can equally call our p. So is to differentiate everything here with respect to x, and to differentiate with respect to x will give you 2ax. I can call it my equation 1. So the next thing is what? Partial z over what? Partial y, which we can call z small letter y, which you can call q. So differentiate here will give you what? 2by. Yes, 2by. Now we can call this equation 2. Now let us add equation 1 and 2 and see what is going to happen. If you add equation 1 and 2, I'm going to have we want to eliminate the a and b totally. We don't want a and b. Okay. Oh, it is even easy. From equation 1, instead of even adding, from equation 1, let's make a subject. Our a will now be equal to p over 2x. And from equation 2, let's make b subject. Our b will now be equal to what? Q over 2y, right? So now let's go to the main equation and substitute them. So in the main equation, we have that our z is equal to what? Ax squared plus by squared. So therefore, z is equal to, our a is something as what? P over 2x in bracket of x squared plus q over 2y in bracket of y squared. So you see that x is taking care of one of the x here, y is taking care of one of the y here. So I am left with that my z is equal to what? P over 2 plus px over 2 plus qy over 2. So if you multiply everybody by 2, you see that I'm going to have that what? Px plus what? Qy is equal to what? 2z. As simple as that. So that is the partial differential equation we are asked to form. You can write it in this form, or you write it in the form zx with big x plus zy with big y is equal to what? 2z. Or you write it as what? X partial z partial x plus y partial z partial y is equal to 2z. So any of the three is the correct solution to that problem. Okay, so we go to the next question. Where is it? Okay, this is the next question, Nicola 1. By eliminating the arbitrarily constant. Let me touch this. Wow, beautiful. I've learned that one. Don't forget. So once you click there, everything will erase instead of erasing it one after the other. So let's go to this particular one. So they gave us that our z. Next page. Sorry. So they gave us that our z is equal to what? A in bracket of x plus y plus b in bracket of x minus y plus abt. Let me shift and write it very well. Where is it? Okay, so we have that what? We have z is equal to what? A in bracket of x plus y plus b in bracket of x minus y plus ABT then plus C. You see that the independent variables here are x, y, and z. X, y, and z. So let us differentiate with respect to all of them. So I'm going to have that partial z, partial x first of all, which is something as saying zx, which is something as saying what? Our p, okay, which is equal to, and we differentiate with respect to x. We're going to have differentiate here with respect to x. I'm going to have just a, because if you open this bracket, you have ax plus ay, so it's just a for this side. So I'm having a here. Differentiate here is going to be plus b here. There is no x in the other side, so I can call this equation 1. So we say partial z over partial y, which we call zy like this, which is q. So differentiate with respect to y here, I'm going to have a. Differentiate with respect to y here, I'm going to have minus b. There is no y here. There is no y here, so I have equation 2. Equation 1, equation 2. So partial z, partial t is equal to, there is no t here, 0. There is no t here, 0. There is t here. So differentiation of t here will give you the ab. So this is ab. So this is equation 3. So now how do we solve this 1, 2, 3 to eliminate our a and b? Is there anything to do to eliminate our a and b? I think yes. But how do we eliminate our a and b? Okay. All right. So now, okay. So what do we do? Consider. Okay, they gave us this. Okay. They say since this is equal to this. Okay. Yes, it's true. Yes, it's true. So now, we know. Let us square this. We know that a plus b all squared plus minus a minus b all squared. If you open this bracket, see that this is going to give you, let's see what it's going to give us. It is going to give you and then this thing is the same thing as where did we get this one? T. Okay, or just leave it. So it's the same as saying a squared plus b squared plus 2ab. Right? This one will give you a squared plus b squared inside this one plus 2ab again. Sorry about that. Let's see what these two will give us. So opening this bracket, let's put it inside the bracket. Square the first one, a squared. Multiply the first one and the second one, double it, 2ab. Square the last one, I'm going to have b squared like this, minus, square the first one, a squared. Multiply the first one and the second one, double it, minus 2ab. Square the last one, I'm going to have b squared. So if I open the bracket, I'm going to have a squared plus 2ab plus b squared. This time this minus a squared. This time this plus 2ab, then minus b squared. So this is taking care of this. Why this is taking care of this? So this 2 is something as saying 4ab. 2ab plus 2ab, 4ab. So having known that, you will see that it will not easy for it to eliminate. So to eliminate that, we are going to be having that this thing now, this thing is something as saying p squared. So this is p squared. This is p squared minus, this is something as saying q squared is equal to, or because we don't know this, instead of using that squared, so we are going to be using instead of using that squared, we're going to be using, so this one now, you see this one is something as this thing, right? So this is partial z over partial x all squared. because a plus b is this. So even if you don't know this, just leave it. Just leave it if you don't know it. Just this is equal to this minus this one is written as partial z partial y all squared is equal to 4. This one is written as partial z partial t, so partial z partial t. So this is the differential equation, as simple as that. Next page. Right, so on this page we have another question to solve. So they said we should eliminate the arbitrarily constant again. We have not even gotten to arbitrary functions. Okay, for arbitrary constant, the first question the question they gave us here is z is equal to x squared plus a, like this, then y squared plus b. Okay, so we have two constants, so we are going to differentiate 2 times. So I'm going to have partial z over partial x, which is equal to what? Which you can call as p, is equal to what? 2x. Yes, 2x into y squared plus b. Hope you know, because this is not separated, they are attached, so you have to attach it. So partial z over partial y, which is something as q, is equal to 2y into s squared plus a. Okay, so now how do we eliminate this? To eliminate this, you see that this thing is something as this. So let's make from let's call this equation 1, let's call this equation 1, equation 2, equation 3. From equation 2 I can make y squared plus b subject to give you p over 2x. Then from equation 3 I can make x squared plus a subject to give you q over 2y. So substitute these two things in this equation 1. So I'm going to have that this is z is equal to, so instead of x squared plus a, I'll put it as what? Q over 2y plus, instead of this one is going to be what? P over 2x. So you have eliminated all the constants. So to clear, multiply everybody by 2xy. So to multiply everybody by 2xy, I'm going to have 2xyz will now be equal to qx plus py. So that is the differential equation that we are asked to form. As simple as that. So we go to the next one, the next question. And next question here gave us z is equal to ax plus by plus cxy. Okay, so now we have three what is it called, 3 constants. So we are going to differentiate 3 times. We have 3 constants, so we are going to differentiate 3 times. So differentiating 3 times, we are going to have, the first one should be partial z over partial x, which we can call p is equal to, differentiate here with respect to x, I have a plus, this is product rule, x and y, you understand? Okay, sorry, not product rule. Differentiate here with respect to x, I'm going to have cy, and this is cy, so I call it equation 1. Okay, so the next one is partial z over partial y, so this is 0. This will give you b plus cx, equation 2. So the third one will now be partial z over partial x partial y. So this one is what we are differentiating again with respect to y, to give you 0, to give you just c. It's giving us just c. And then it's the same thing as even partial z over partial y partial x. It will still give you, differentiate this with respect to x, you still get c again. So now how do we now substitute so that everything will go? So since we know that, and this thing is represented with s, so since we know that this thing is c, if we put it here now, we are left with a, this is q, don't forget. How do we put it now so that we can get what we want? Yes, The idea is here. So let us substitute c that we already know in equation 1 and 2. So from equation 1, you should know from equation 1, so you have that your p will now be equal to a plus s. Don't forget that we call this s. And from equation 2, your q will now be equal to what? B plus sy. There is y in it. Your c is s, which is partial this, so you are going to have sx. So let's make a subject here. So a here will now be p minus sy. Yb here will now be q minus sx. So now put it in the main equation. So if you put it in this main equation, we have that z will now be equal to a. Our a is the same thing as saying p minus sy. So this is p minus sy all bracket x. From here we are substituting here, then plus our b is the same thing as saying q minus sx. So we have q minus sx all y. Okay, then plus our c we have gotten as s, so sx y. So this is the differential equation, as simple as that. See, so erase all. So you see, they got the same thing. Oh, we can even open the bracket. If you open the bracket, you wouldn't get this. If you open the bracket, you will get this. Yes, if you open the bracket, you will get this. As simple as that. You see, they got the same thing here as a, got the same thing here as b. So if you substitute everybody here and open the bracket, you will not get this finally as your answer, because some will subtract each other. So let's now move to elimination, eliminating arbitrarily constants. Arbitrary functions, eliminating arbitrary functions. Let's go to the next page. So eliminating arbitrary functions, I think I'm going to solve 2 questions here, and then we are good to go. Don't have time. The time has already, maybe in the next video we'll solve more questions. So now, so in this first video, in this first question here, eliminating forming differential equation by eliminating the arbitrary functions. So we have that z is equal to f of x minus y. Okay, so now we have just one function. So we have we have 2 variables, so we're going to differentiate twice. So I'm going to have that zx with respect to s will give you f prime of x minus y. Okay, so zy will give you minus f prime of x comma y, s minus y. So I hope you know, because differentiation of minus y will give you minus, so that's the main reason for this minus. So if we add the both of them, if we add equation 1 and 2, we are going to have that zx plus zy is equal to 0, and everything is gone. That's what we are looking for. Is it the same thing that he got? Where did he do that? You see it. He got p plus q is equal to 0. So this is something as p, and this is something as q is equal to 0. So that's all. So let's now go to the next question. That is question number 2. And question number 2 here said they gave us file of x plus y plus z, comma, x squared plus y squared minus z squared equal to 0. So they say we should form a partial differential equation by eliminating the arbitrary function file. Okay, so but we know, don't forget that we know that our u is equal to our x plus y plus z, and then our v is equal to s squared plus, or we can say let's not, we know, let's, so that it will be easier, s plus y squared minus z squared. So the function will now be just u and v like this, which is equal to 0. So differentiate file of u like this will now be equal to just file prime of u and v, right? Okay, so and file prime of v is the same thing, is the same file prime of u and v. So if you subtract the two of them, you're going to have that file prime of u minus phi prime of v is equal to 0, right? Yes, if you subtract the two of them, that's what you are going to get. So what does that mean? Problem. I think this one is a bit difficult. We get this differentiating 35 with respect to w, r, t and x. Okay, yeah, I think this is what we're supposed to get, but they're not getting the same thing with me. So maybe we'll find out where the problem is, then in the next video we'll now resolve it. So I think I'm going to stop here. So thank you very much for watching. Please like, share, subscribe, and done. The next video we'll check it out.